Well, good morning, everyone. How you guys are doing? I might not be turned on my camera because I have seen similar problems earlier that when I turn on my camera, somehow my system just got hanged. So that's why I'm not trying to turn on my camera. So yes, very good evening, very good morning. Sorry, Vishal. I think Ekta has also joined. So you have not joined last class, Ekta. What happened? I remember like yesterday you were not in the class. Suraj was there. I hope Ritik was also there. Not sure about Manoj. Manoj was there or not. Yeah, Vishal was there. Suraj was there. Can you guys hear me clearly? Thank you, Vishal and Ritik, for confirming. So we'll wait for some more minute, and then our we'll start listening all of your doubts and all of your queries and some of the topics which we want to cover today. Well, good morning, Hariharan. So guys, it's to office meetings. They have UK timings. I know. So while I was in IBM, I was also in the UK shift, and that UK shift start from in IBM it was starting from like afternoon 2 o'clock till 10 o'clock. So yes, that would be the problematic. Hmm. Yes, Hariharan, I'm doing very nice. So just woke up from our last call. So yeah, feeling energetic. So guys, I think in from last three classes we were fully doing the problem solving, right? And all the problems we are trying to solve it in best time complexities. We have also seen in some of the places those problems could be solved with brute force or linear approaches, right? But at the end, for finding out the best solution, and when I'm saying best solution, it means based on the time complexity, right? That whatever the best solution we can reach, where our time complexity is less, we try to reach to that place. And for binary search, the time complexity comes to log n, because what we do here, we divide our array, and after dividing our array, we leave out the rest part. Like if we had if there is a length of 10 elements in one array, so we'll first divide this array into half. So we'll find out the mid element. Then after finding out the mid element, we try to go left side or right side. So once we are going into left, so now all of rest of right side part we will not be taking care of. Correct? So that's why the binary search is best, because it's just divide your array into half, and then again you try to reduce your scope, right? So first you start with 0 to 10, then you go for 0 to 5, then you go for 0 to 2, and then you go for 0 to 1. That's how you are reducing your search space to the minimal elements. So that's why binary search is best. And you have seen a lot of problem which we have done. I think till now we have done 11 problems, right? And in those 11 problems we have implemented binary search. And once we are implementing or trying to solve problems with binary search, automatically we were seeing that a lot of solutions complexity got reduced from n to log n. And that was our goal also, right? So that's why actually we were talking that much about binary search, and that much we're trying to solve the problems also. And yeah, some of the problems which we have solved, like array splitting or subset of sum, and like in yesterday class we have covered like median of sorted arrays, right? These are very hard level questions, right? If you will find these questions in Lead Code or somewhere else, some of the problems websites, you will find the categories for these questions are very hard. And these type of questions, I'm sure people are asking in tier one companies like Google, Microsoft, Amazon, and LinkedIn, Netflix. So these type of companies are asking these like complexities questions, right? And apart from that, most of the questions were coming into the medium categories. Like if you remember about the book allocation or pair of topics or like painter partition problem, or there was cow aggregation problem. Aggregation, like yeah, there was one like aggregated cows also was there, and I think there was a square root problem also was there, right? And there was like some easy problems was also there, like not a triangle was the easy problem. And in yesterday class peak in yesterday class peak yeah, find peak element, that was also easy problems. So I think Relwell has provided us like different categories of questions where they have tried to fit all easy questions as well as the medium level and as well as the hard level. So if we are good with understanding the medium level questions, so there are a lot of chances in very like in a lot of interviews we are going to get one or two medium question and one hard question. So that's why I would suggest to everyone, try to solve more to more medium questions, because in any of the like companies interviews, like in the PayPal also, when I have given the interviews, so there was I think 4 to 5 rounds. So in the 1 or 2 rounds they simply ask these medium level questions, because that would be half an hour interview, and in that half an hour interview they will give you these problems and you have to solve it in half an hour. So they will look for, they will choose the medium complexities questions. So I would suggest to everyone that go for try to solve these medium problems as well, which Relevol has provided you. But apart from that, go to these Lead Code side, and Lead Code or Hacker Earth, Hacker Rank, Code Force, a lot of like programming or a lot of problem solving websites are there, and try to pick all the medium categories questions. Try to, like, if you are stuck in hard, that's fine, but first start with easy, just for practice, for creating the base. And then once you are like confident in the solving easy problems, try to solve as many as medium complexities problems you guys can solve. And that definitely will solve, that definitely will help you to clear a lot of interviews round. Okay guys, so that's what I want to tell you guys here, that how much importance these problems has. And I think some of the people could be like, because see, we have covered these things in 4 to 5 days, so you guys might be not have practiced it till now. But in our class, while I was explaining the logics to you, or if you guys have already seen some of the code, so I want from you guys to tell me which are the problems you guys have seen, which are little bit complex to understand, or you guys faced some difficulties there. So I will choose those problems today, and I will try to explain the logic again for them, and try to show you code also. Okay, okay, guys. So let's, because I think we have 12 people right now. So I think you guys can just write it down here, and then based on that, whatever the first maximum problem is coming, we will try with that. So Hariharan is written split array. That's a hard level question and very nice question. Okay, so Vishal is saying if you could discuss median one again. So okay, we got split, we got median. What about next question, guys? So we got only right now it's 1 to 1. So Arad is saying sex tuplet. So this is a third category. This is also tough, I think, question. All three are tough categories question. Okay. So we got 1 1 1. Subsums. Okay. So Hariharan is also comes with subsum, which was I think in the practice binary search 1. So that question, in that we were getting the subsums of sets. That was also a hard question. Okay. Did we do book allocation already? Yes, Ekta. In last class, we have done the book allocation. But if you want, if we got the time at the end, we can go for book allocation again. So I think right now we have got all the different questions. Any questions? Do you guys 12 people are there? So you guys can tell me which one you think which we should go, or you guys want first to clear some of the doubts in these problems. So I think in the subset or subsum, they want to understand some of the doubts, right? So let's see. So okay, guys. So I think starting half an hour, we can go for your doubts, okay, and then we can try to pick any of the problems. Okay. So let's start with let's start with seeing the subset array problem. Okay. Let's just like I will like you guys can turn on your mic and you guys can tell me. I will share my screen for subset array code, and then you guys can tell me where you guys are facing problem, right, in that code. So I could explain that part. Is it good? We can take each problem one by one, and if you are guys are somewhere facing some problem in that problem, in that question, we will just talk about that one first, and then at the end there are some questions where we can start logic, understanding logic from starting. Okay, so let me first open the subset array problem. Okay, so whoever is facing problem with subset array, let's start with that. So let me first share my screen and open the code, and you guys can one by one start. uh, Whoever the person can start by one. So let me open the subset problem first. Yeah, this is our subset problem. Let's start with this. Okay, so let's who is going to go first? Hariharan was there. He was asking one question.
Oh, yes, sir.
So Hariharan, you can speak. Yeah. What was the problem you were having?
Sir, I didn't understand the code and I was
Mhm.
confused with the logic also.
Sorry, I didn't hear you. What are you saying? Can you
I
repeat it?
didn't understand the code and I was also confused in logic also.
Okay, so in the logic you also confused. Okay,
Yes,
so you want me to explain the whole logic again, right?
yes, sir.
Okay, that's fine. Let me, okay, Aryan, I noted down this form, but let me see if anyone else has any problem with that logic, who has already seen the logic and code. So yeah, anyone else who has any problem with that in a subset problem, that person can speak. Or we could start with subset only, if you guys want. So everyone wants to understand the subset problem first. Let me know in the chat so we can start the logic from there. Hariana says yes, okay. Vishal is okay. Arad is okay. Okay, so let's start with subset problem, guys. Okay, that's our today's first problem which we are going to solve. So this was, I think, in the first class, and yeah. So this was our problem: subsets having sum between A and B. Okay, so what they are saying, we have been given one array with n elements, and we need to find the number of subsets which will have a sum between A and B, right? And you can see the array's element are 1 comma minus 2 comma 3. And now if we just talk about logic first, not about the code. So let's see how. Let me go back to this Microsoft OneNote, and let me first write this array quickly. So 1 comma minus 2 comma 3. 1 comma minus 2 comma 3, right? This is our array, and they are saying to find it out the subset of this array. Okay, so it's a mathematical terms. So when we find it out the subsets of any of the numbers, like if in the mathematics, if somebody is giving you three numbers like this, minus 1 2 comma 3, and they are saying you to find the subset of these three numbers, so the subset of these three numbers would be 0. This would be the first subset. Second would be the 1. Third would be the minus 2. There would be a 3. Then there would be 1 comma minus 2. This could be the one subset. And then there could be minus 2 comma 3. This could be one subset. And the last could be all three elements, 1 comma minus 2 comma 3. Let's add how many subsets we got. 1, 2, 3, 4, 5, 6, 7. So we got 7 subsets, right? So that's how they have created one formula also. So if there are three numbers, so like a number of 3, so we will get 2 to the power 3 minus 1, 7. That many subsets. So that's what they have created the formula for n numbers also. So if there are n numbers, the formula will be look like this, 2 की power n minus 1. So n would be the number of elements. That's how we create the subsets. Okay, guys. So that's how we create the subsets. Let me see if I miss any number. Have we missed any number? I think, yeah, we missed 1 comma 3. Okay. I think we missed the 1 comma 3 also. So now this would be 8 subset, right? Okay, let me erase this one. Correct, guys? We missed that one. I think, not sure you guys have noticed or commented in the chat, but we got the 8 element. So we can say if there is a number, if there is a like 3 numbers, so we can say the subset would be 2 की power 3 is equal to 8, right? So we can generate the formula also for there. If there is n number, so there would be subset of 2 की power n. But we somehow, while we giving it, we just ignore this 0 part. So that's why, like, if you will try to find out the formula in internet, so they will give it 2 की power n minus 1. So that's why actually I got remember when I write 2 की power n minus 1 and I was still considering 0, then I got remember like I am missing some elements here. So that's how I got to know that I'm missing 1 comma 3. Okay, but yeah, this is the formula like without including 0, without including 0. And this formula is like everyone knows that, like they have to remember this formula. So every time they remember it. So that's how, guys, we create the subset. Are we good with understanding this part? Hariharan or Vishal or Arad? Let me see in the chat first. Yeah, it's still one less. Yeah. Yeah. Okay. So that's how we create the subsets in the mathematics. Okay. Let's clear it out very quickly. Now what we need to do, guys, we need to do the similar thing programmatically, right? So if there are 3 numbers in this array, we need to find it out the subset of this. Correct? And then what our question is saying, we only do not need to find the subsets. We also have to find out the sum of subsets. So they are saying subsets having sum. Correct? And that sum should be between A and B. That sum should be between A and B. Correct? So let's see. In this problem, if you want to, again, let me try to create the subsets for this. So this would be 1, like 0 would by default. Then there would be a 1. Then there would be 1 comma minus 2, right? It should be 8 subset, right? 1 comma 3. This time I will not miss 1 comma 3. Then it would be minus 2 comma 3. And then like minus 2 and minus 3 will also come individually. And then 1 comma minus 2 comma 3, right? And they have given A key value, the value of A is a minus 1 and value of B is 2. And they are saying the sum of these subsets should be between these two. And tell me how many subsets are those, how many subsets we have, so the sum of those subsets lying between these values. Okay, let's see. Let's sum these values. 0, comma 1, 1 comma minus 2 is minus 1, 1 comma 3 is 4, minus 2 comma 3 will be 1, minus 2 will automatically come, 3 will come. And then if we add all these 3 numbers, so we'll get 3 plus 4 minus 2, it will be 2. Correct? So let's see how many numbers are lying between this. So see 0, is it lying between this? Yes. So first number, count is equal to, like we can say one result variable here, or count anything, and we can add it here, result. So first was 0. I'm just squaring it out, whoever is passing the condition. So 1, 1, this one is also, so plus 1, this one is also plus 1, 4 it's not, this one is again plus 1, this one is not, because minus 2 is not, like it's not lying between these two. 3 is also not lying between them. This one is this one. 1 2 3 4 5. That should be our answer. Let's see if we are missing anything. Yeah, output is 5. Understood, Hariharan and everyone? Sir, why minus 2 comma 3 coming again? Minus 2 comma 3 is coming again. Where is that? Yeah, this is individual. Here I have taken it as a set, when I was showing you mathematically, you remember I showed you minus 2 comma 3 will individually will also come. They will also be part of this set, right? In mathematics, first whenever we create the subsets, Hariharan or everyone, first we take all individual elements. You can see I have taken 1, then I've taken minus 2, then I've taken 3, then combination of them. Then you can see I've taken 1 comma minus 2, then I've taken 1 comma 3, then I've taken minus 2 comma 3, combination. It's a combination. Then all three, 1 comma minus 2 comma 3. Okay. Yes. So that's what we need to do it here, guys. First, we need to create the subset, and then we need to find it out then we need to find it out that my values are coming between these two or not. Correct. So for creating a subset, I think we already in our code. If I go into the code part, so yes, before going into that, there was one problem actually, and that problem was in the question only. That problem was in question. Let me show you. Okay, why I'm going here? Okay, yeah. Yeah, so that problem was in question. So if you open the question in this URL, so you will see that you can see the value of n, like the number of elements in an array could be between 1 to 34. 1 to 34. So that's the problem, because as I told you, the formula is 2 ki power n, right? If there is n elements, we have to create the 2 ki power n subsets, right, guys? If in our scenario, they are telling that n could be between 34. That's what they are telling. So the maximum subset which we could create, that could be 2 ki power 34 subset, which is too long number, which is too big array, right, guys? Which is too big array. So that's why while solving this problem, what they have suggested, the best way is to break this array. So like if you consider, if we have 34 elements, so if we will break this array, so at one side we will get 2 ki power 17, and next at the right side we will get 2 ki power 17. Like each array will be divided into 2 ki power 17 subsets. So we can easily handle 2 ki power 17 combination of elements, but 2 ki power 34 is too big, and our problem will take a lot of time, or might be some storage problem could also come there, or it will take a lot of time. Rather than that, what we will do, we will divide it, and parallelly we can execute like 2 ki power 17 at one time, and again after that, after some time, we can go for the 2 ki power 17 next, remaining 2 ki power 17. So that's what, guys. If you will look into the code, so you can see I have created one array, and in this array I was just passing 0 to n by 2 element, and I am trying to create this recursive function. This recursive function is simply just creating this array. Simply it is creating this array. Sum of subsets. This array, this recursive function is creating. Okay, so but rather than creating this sum of subset array for all of number, I'm just dividing it into. So like in this scenario, I will first pass 1 comma minus 2, and then the next will be 3 only, according to so say 0 to n by 2, and then n by 2 say n minus 1. Correct. So that's what the logic I have written it here, or n by 2 plus 1, I can say n by 2 plus 1. That's what the logic we have written. You can see here. So first I was taking n by 2, then I was taking the n by 2 plus 1. Correct. So let's see. In our case, n would be 3. In this example, n would be 3. So n by 2 will become 1. So we'll take 0 to 1, these two elements, and then n by 2 plus 1 would be the second element, and n minus 1 is also this. So this only last element. Okay. So that's how we are first creating the subset sum of this array. So let's create subset sum of these two arrays. So first we'll take 1 comma minus 2. Let's create all the subset of this. So first subset for this would be 1 comma minus 2, right? And 0 could also, 0 will also be there. 0, 1 comma minus 2 comma 0. Then 1 comma minus 2. This particular pair 1 comma minus 2, right? I think only these four combinations are there. Now let's take the sum of these arrays, which would be 1 comma minus 2 comma 0 comma minus 1, right guys? And then we will take this is our array 1, half of array. Then we will take array 2, which would be, we are only passing 3. So the subset of this would be 0 comma 3 only. And even the subset of sum will also be 0 comma 3. Correct guys? This part we understood or not? Everyone? Hariharan and Vishal, Arad, everyone. This part we understood? Okay, let's see this part in code also. So see, this is the first array which we passed 0 to ny2. We created the generate subset sum recursive with that method. Then again we created the second array, and now we got the second array and we are sorting out the second array because we are going to do the like binary search on the second array only. Okay, that's why we have sorted it out. But in our case, we have already sorted it out. 0 comma 3, this is second array. So see, the final array would look like this. Final array will look like this. 1 comma minus 2 comma 0 comma minus 1, and then the second array would look like this. 0 comma 3. Correct? And this could be little bit, see, these values could be little bit wrong because I have taken randomly. So let's look into the code and take these value correctly. Okay, so I have already put the console here for second subset and first subset. Let's look for that. You can see 0 comma 3, this is correct, and the first array looks like this: minus 1 comma 1 minus 2 comma 0. You can see this is the console which I printed it out. So let's see, minus 1. So let me correct these values as the logic will run according to that. Right now these are randomly, right? I have edited it out, but now we'll correct it to as the program is running. So minus 1 comma 1 comma minus 2 comma 0, right? Or like earlier will also work. Like if we have taken the earlier also, I think let's revert it back. I can revert it back or not? Yes, I can. I think that will not create any problem if we are going with this also, because we have to do binary search on this one. So you have already sorted it out. Yeah, 1 comma minus 2 comma 0 1 minus 1. So this is the array 1 which we have created with this element. Again I'm explaining because I did little bit mess here, so that's why I'm just explaining it again. So this is the first array, guys. First half of array 1 comma minus 2. I created the subset for that. I added all the subsets. I added all the I like produced the sum of subsets. You can see 1 already there, minus 2 0, and 1 comma minus 2 minus 1. Then we taken the second half of array. There was only one element, so the subsets for this element would be 0 comma 3. And then if we add all those things, so 0 comma 3 will only be there. Two numbers will be there. Then we sorted it out because we are going to do binary search on this array. Okay, that was the thing which we have done till now. Now what we need to do, we need to add these two arrays. We need to add these two arrays, and we need to find that the sum of our arrays should be between A and B. Should be between A and B. Correct? So see, if we take one element from here, let's consider that one element X, and we take the one element from Y, like from the array 2, and let's consider that element as a Y. So what is condition we are having here? I think this is very important point, everyone. X plus Y equal to A, or X plus Y equal to B, because equal to or less than, or greater than or equal to, because the value should be between A and B. So if we add two elements from these two different arrays, So the values which should we get, it should be between A and B. Correct? That was our condition. Let me show you in the problem also. Yeah. So they are saying subsets having sum between A and B. So now if we are adding these two subsets, 1 comma 0, one element from array 1 and one element from the array 2. So our sum should be between A and B. So everyone has understood this condition or not? First, let me know in the chat this condition. Let me look into the chat. Any doubt in that condition? No. Okay. So now what we will do, guys, we will do binary search on this one, on the y part. So when we have to do binary search on this one, it means we have to find something here. Correct? So rather than doing x plus y, we will transform this equations. So this equation will look like this: y equal to a minus x, or same y equal to b minus y, b minus x. So we have to now find everything in y only. We have to find everything in y. It means it would be second array. So we have to find everything in the second array. Correct? So here in this case, because we have to take the lower bound. 1 minute, guys. So let me write it like this: A, B. This is the condition, right? X plus y should be between A and B. So while we are calculating, while we are fetching out the value of y for A, it should be lower bound, because it's a lower bound. Lesser than that, we cannot go for that. And for B, it would be upper bound. So value of A plus y, x plus y will be between these two, lower bound and upper bound. Whatever value we are going to give for x plus y, let's see. Value of A is -1 and value of B is 3. What is value of B? Value of B is 2. Correct? So now let's take the x plus y. So let's say 1 plus 1 comma 0. 1 comma 0. It would be 1, right? If we will add them, it would be 1, right? So 1 is between them. Yes. So we have to find the lower bound, and we can see the upper bound. So the lower bound is -1 and upper bound is 2. In similar ways, we are going to do here also. While we are trying to fetch the value of y in the array 2, we have to find it out the lower bound for those elements. Correct? So let's see. Let's take one example. Let's take the same array and let's calculate the. Let's try to find out the y. Okay. So let's say. So let's see the first condition. When I'm taking the first element from the array 1, that is x is equal to 1 and a is equal to -1, b is equal to 2. These values are given, right? But we have taken the first element. Let's calculate the y here. First y for calculating the lower bound. So y is equal to a minus x. So value of a is 1 and -1 will make it 2. So now we have to find the lower bound for 2. Lower bound for 2. Right, guys? In array y, in array 2. Let's take the upper bound now. B minus x. Value of b is 2. Value of x is -1. So it will be 3. So we need to find the upper bound for 3. Let's try to find it out. So what would be the lower bound for 2, guys, in array 2? You guys tell me. Lower bound for 2 in array 2. Everyone in the chat, just see this array y, array 2, and just let's find it out the lower bound for 2. What would be the lower bound here? Okay, so this one is not getting. Hariharan, you can speak up. Which part? Lower bound and upper bound part?
The thing which you have written last.
This one, right?
Yes.
Okay, so see, this part you understood? Lower bound and upper bound here?
Yes, sir.
Yes, sir. Okay, so see, what we are trying to do here, Hariharan, that x, as we know that the value of x plus y should be between a and b, correct? So the values, so for them, for value x plus y, lower bound would be A and upper bound would be B. Correct? Because these are the conditions where we are going to lie between. So so now we have to apply our binary search. Correct? So for and we are saying we can only apply binary search in one array. So rather than calculating x plus y, because if we are going to calculate x plus y, we need two loops, right? One loop in first array, second loop in second array. Then we can get the x plus y and then we can compare it. But that's a n square complexity, right? Or m and like if they are both are not same array, so it will be m cross n complexity. But rather than that, we will try to find out some some binary search solution. For binary search, we if somehow we can sort one array and then from other array we can find that the value is residing between these two, between the elements, we can try to do that. So that's what we did. So the condition was x plus y is equal to a, x plus y is equal to b. Rather than looking into both arrays, we could look in one array also, right? So that's what we are trying to do. In y, we are trying to look for that. So we have done a minus x and b minus x. So while calculating the first value for y, this will be the lower bound, because we are trying to do with a. We are trying to do with a, and a was lower bound, right? And for b, when we are trying to calculate the same value for y for with the help of b, that would be the upper bound. That would be the upper bound. Correct? So see, the other example could be, right? So let's see. Let's try to find out first the lower bound for this. Then I think it will make more sense. So let's see. So the lower bound for 2 in the array 1, in the array 2, it would be 1, right? Because the element would be residing here. And upper bound for 3 would be 2. Correct? Would be 2. So now we got the range for now we got the range that between this 1 and 2, like 1 and 2, between these two elements, the range is 2 1 comma 2. And if we subtract these two values, 2 minus 1, so we'll get 1 here, right? We'll get 1 here. So now we can see, uh, now what we can say with this value, with the 1, that the elements from the element from the array 1, which was minus, okay, I think something is okay. Oh guys, you guys didn't tell me. I was not taking the minus 1. I was, see, this was the first element, right? And we have taken the minus 1. So that's why I'm thinking like why I'm that's why I was thinking why I'm not getting the right value. Okay, so see, we are taking about the minus 1. Let's see, minus 1, and with this array, how many combinations we can make? Minus plus 0 would be minus 1. Minus 1 plus 3 would be 2. So we should get 2 right here. So we are getting 1. I think we are missing 1 minute. So value of a is minus 1. Oh, okay. Minus 1 was here. See guys, we have done little bit mistake here. Okay. We have done little bit wrong here. So let me, I think, do it again. We have taken the wrong values actually at all. Okay. I think Hariharan, you can understand it again. Okay.
Hello, sir.
Okay. So now, yeah.
Sir, how these X, A, and B values are taken?
A and B value.
X, also X value.
X value we are taking from array 1.
Array 1 first element or one?
Yeah, first element only. First
Okay.
element. So we will see what we are trying to do here. We will try to find it out. We will take each element from here. Then we will try to find it out the range of that element into this. Like we're trying to find it out the combination. How many combination we could create while taking one element from here and all the element from here. We are trying to find out the combination, that how many elements we could create from here, which the sum of those combination could lie between A and B. That's what we are trying to do. So let's see. Just rather than going through that, let's see, one will create one combination with 0, and one will create another combination with 3, right? That's only this element can create two combination, right guys? And let's see if we let's try to create the sum of these two, 1 and 4. So we can see only one would be lying between these two, so I should be getting here one only. I should be getting here one only, because not 4 will not be lying between A and B. Now let's do minus 2. X is equal to minus 2. How many combination it will create? Minus 2 comma 0, minus 2 comma 3. Correct? This now add it. Minus 2 will come here, and here it will 1 will come. So you can say again we are only taking 1 here. This is the solution which will lie between them. Correct? X is equal to minus 2, x is equal to 1. Now let's take x is equal to 0. See how many combinations it will create. 0 comma 0, 1 combination, and 0 comma 3. So 0 and 3, sum of them. So only 0 will be lying here. This is the third element, right? Now let's take minus 1. When x is equal to minus 1, it will create two combinations, minus 1 comma 0, minus 1 comma 3. Let's add it. Minus 1 will come here, here it will 2. So this will create two combinations. Minus will also lie between there, and 2 will also lie between there. So you can see how many total combinations are there. 1, 2, 3, 4, 5. And that's what answer is 5. Now you understood, Hariharan, what is happening here? X plus Y should be lie between A and B.
Yeah, yes, sir. Understood.
Yes, right. So rather than see, because now if we will do X plus Y, and then we compare it between A and B, it will take n square loop, or n cross m. N would be the array length of first array, and m would be length of second array. So rather than doing that, we have to find something where we can do only iteration in one loop, and then we can find it out that how many combination we can create. So that's why we are going into the only one loop. That's why we written y is equal to a minus x, y is equal to b minus x. Because we already know value of a and b, we'll just subtract these two values from a and b, and we try to find it out the lower and upper bound. Correct? So once we will find out the lower and upper bound, we'll subtract them, and we'll say that many combination we can only create. Because lower bound will give us the less, like the lower position. From there addition, like from there the value will be lying between A and B, and upper bound will give us the maximum position. Like till here only the only the values can lie of A and if we will add A plus B. Guys, you guys might be facing little bit difficulty to understand this, but let me explain it again. Why we are sorting the array, and why we are trying to find out the lower bound and upper bound. That's the question we are trying to answer here. Correct? So x plus y we have understood. That's very small thing. We can quickly do that with the m and n. The loop would be m and n there. Correct? But rather than doing that, what we are doing, we are trying to search the elements in one array only, 0, 3. And while searching elements here, we are trying to find it out the lower and upper bound. And why we are trying to find out lower bound? Because lower bound will give us the minimum position. From there the element will be if we will sum the two elements, we will be lying between A and B. That's the minimum position. And upper bound will give us the maximum position. Till there, if you will add x and y, it will be lying between A and B. And if you want to see that, let's see, y is equal to a minus x. Let's take one only. Let's take one only. Let's create y is equal to value of a is minus 1, and value of x is 1. So this will be 0, right? Now we need to find out the 0 lower bound for 0. So it will tell us that the value of 1, if we will add 1 plus 0, this 0, then the where would be the minimum position from where the sum of those two elements will lie between these two. So you see for the 0, the lower bound is 0 only at the 0 position. Correct? At the 0 position. Let's find out the upper bound, which would be b minus x. V minus x. V would be 2 and x is equal to 1, which is 1. Now let's find out the upper bound for 1. which would be 1, because it will lie here. Now if we subtract these two values, 1 minus 0 is equal to 1. So it is saying that if we are taking 1 here, it will only create one combination which is going to lie between A and B. And if you want to see that, let's see that combination of 1 comma 0, 1 comma 3. So the first combination will give 1, second combination will give 4. You can see only 1 will be lying between A and B, not 4. So that's what the upper bound and lower bound is telling us, that how many combinations are going to lie between A and B, which are going to follow this violation of -1 and 2. Correct? So that's what in one array we are able to find it out, if we can find it out the lower and upper bound. Hariharan understood this part now? So Ekta is saying, sir, so did not be a less than equal to a plus x plus y and less than equal to b instead of greater than equal? Where in this, which condition? Oh yes, Ekta, you're right. It should be less than equal. Correct. Yeah. Yes, right, Ekta. No, that's right. I find it. Yeah. Okay. So now let's see in the code, the similar thing is happening. So first we have sorted it out this array, and then we are iterating at the first first subset sum in this one, iterating on this one, right? And then we are again doing the similar thing. So second subset, we are passing in lower bound. You can see a minus first subset sum I and b minus first element from the first array, and then same element from the first array, and then we are subtracting from a minus 1, a minus and b minus, like we are doing here. A minus first element, b minus first element. That's what we are doing here. And then we are trying to find out the lower bound and upper bound. And this one is not needed, but even if still you are looking for this value will always be 0. This value will always be 0, because second subset sum 0 is always be, because you can see 0 comma 3, always 0 will come at the first position. So that's what we are doing here. And then we are subtracting it q minus p and adding it into the count. Okay guys, that's what happening here in the code also. Lower and upper bound have many use cases. I didn't know when I learned it. See, what I have seen with the lower bound and upper bound, guys, I think when we have a sorted array, when we have two arrays, or in the same array also, in a same array also, and when we want to create the combination, see in this we can understood with this problem only. So so in this array, we can say, in this question, we can say we have two arrays, right? And with first array, we got one element, and we want to know how many, like what would be the range here? What would be the range of element here, which could satisfy our condition, which could satisfy our condition. So every time when you have these type of scenarios where you have to find out the range of elements which is going to satisfy a condition, then I think lower bound and upper bound is always going to help you. And we can only calculate lower bound and upper bound in sorted array only, because sorted array elements, in sorted array we always have element in one order, right? So like always the greater one will be on the right side, lower one will be in the left side. So that's why so lower bound will always give us the lowest position from where the condition could start satisfying, and upper bound will give us the largest position in that array, that till here only the condition will fulfill. Right now we have, our condition was that the sum of those two elements should be between a and b. Then we have to find out the range. In some of the problem you have seen, in the same array we are trying to find it out, that that the sum of those elements. I think I remember one of the problem was there where we are trying to find out the subset in the same array, right? There was minus 2 comma I remember it was array split problem, or might be uh, sex tuplet problem, might be that would be there, where we are trying to find out the things in same array. And there also we were looking for the upper, looking for the range there, right? So those are the scenarios I have seen, that the upper bound and lower bound are many, are we can use it there. Okay, so are we good with the first question? Yeah, I think in sex tuples only. In the same array, we were trying to look for something there, that the equation should match. See, in sex tuplets also, the condition was there, right? The element from this array should equal to the other element, and then we have to find out the range also. Yes, you remember in the sex tuplets also, we have to match the condition that the three elements from here, the sum of those three elements should match there. Correct. Yes, almost same as this one. So I think that's what we can generate, or we can say the pattern which we are saying for lower bound and upper bound, that we will have one condition, we will have one sorted array, and now in another array we need to find it out what are the maximum range which we could have where the condition is satisfying, yes. I that you guys can also remember in that way only. The lower bound and upper bound, you are going to find it out when we have to satisfy one condition, and we have one sorted array, another unsorted array. So from unsorted array we will take one element, and then we will find it out how many range, how much range we have in the sorted array which could satisfy our condition. That's what we are doing everywhere, right guys? Okay, let's move into the next question, guys. Now let's move into the next question. What is the next question which you want me to go through? Let me know where you guys face the problem. Split array, okay. Anyone else, or everyone agrees with the split array? Okay, so let's jump into the split. Yeah, let's start with understanding logic only. Okay. So a split array, and I think that the problem which we have solved yesterday, I think the book allocation, and the painter partition, and there was one more, cow aggregation, aggregated cows, right? These all four problems are similar. Split arrays and the problems which we have discussed yesterday, all problems are similar. Sure, after split array we'll go for median. Okay. Okay, so let's see our split array problem. Okay, so now they are saying you will be given an array which is having n elements, and you will also be given a number k, which will, the values of k will be lying between 1 to n. Now we need to split our array into k segments such that the maximum sum of segment is the minimum possible. So like we have to create a segment here, and once we are creating the segment, so the maximum sum of those segments should be minimum possible. Okay, so let's understand this problem. Let's take the same example, 1 2 3 4, this one, right? So 1 2 3 4, this is our array, and they are given one value to us, k, which where they are saying the k is 3, and we need to split this array in a way so the maximum sum of those segments should be minimum. Right? So let's divide this array into 3 parts, and let's see where we are getting the maximum sum, and those maximum sum should be minimum. How many positions we can keep these elements? So let's create 3 segments here. So this is first segment, this is second segment. So first segment would be this, second segment, and third segment. Let's try to divide these arrays, so these elements. So let's keep I'm keeping First element here only, second element here, and rest of elements here, 3, 4. Let's now add all the sum of, let's now find out the sum of these segments. So here it would be 7, here it would be 2, here it would be 1, right? So the maximum sum of segment is here 7. Correct, guys? Maximum sum of segment, if we like split our elements in this way, we will get maximum sum is 7. Let's try another approach. Let's try another approach where we will keep 1, 2 here, 3 here, 4 here, right? Correct. Let's now again create the, let's again find out the maximum sum here. So it would be 3, 3, 4. The 4 would be the maximum sum here. Correct. Is there any other way we can divide our elements? No, right? This is only, no, yeah, there is another way also, which is this. Let me take another color here. There is one more way to divide our elements, which is like this: 1, 2, 3, and 4. So the maximum sum will be 5 here. Right, guys? So now what the question was saying, we have to split our elements in these three. We have to split our elements in these 3 segments. After that, once we have splitted our element, we have to find out the maximum sum of segments. We have already find it out, the maximum sum of segments. And then we have to find it out what is the minimum in all of these combinations. And the minimum is this one, and this would be our answer. This would be our answer. You can see answer is 4. Understood the logic, everyone? Okay, let's see. 1, 2, 3, 4. Output is 5. Oh, okay. You guys are telling the, oh, okay. Yeah. Okay. So now that's what the logic here. That's what the problem. We need to find it out. Okay. So let's now look into solving it out. How we are going to solve it. And again, I told you, whenever we are getting maximum of minimum, minimum of maximum, I think on those in those scenarios, binary search is best, because because you know, you have to find it out the maximum out of minimum, right? So like looks like we have to do the partitions here. We have to do the partitions here, which will tell us that we have now reached the maximum. Now you can look for other element. Now you can look for another segments. Okay, let's not talk about that. So let's see. Now we will do now. So our approach will be here, guys. 1 minute. Yeah. So our approach will be here, guys. We will now go opposite. We will go the opposite. We will guess like these solutions 7, 4, 5. We have somehow we know that 7 could be our minimum sum. 7 could be our minimum sum, right? Or 5 could be our minimum sum, or 4 could be our minimum sum. Somehow we are going to guess this thing, right? So for that, we are going to create a search space or a range where our loop is going to run, right? So that for that, what we are going to do here, we are just simply consider one condition here. If k is equal to 1, if we have to do only one partition, if we have to do only one partition, then the maximum sum would, like by default, will be all the added elements. So maximum sum for that condition would be all the added elements. So 4, 3, 7, 2, 9, and 10. So the maximum sum, if k is equal to 1, would be 10, right? Or if the maximum maximum segment is same as the number of elements, which is 4, then all the elements will be kept in one segment and the maximum would be 4 there. Correct, guys? The maximum would be 4 there. So now we can see we are getting one range that whatever segment we need to do, like how many segment we need to do, is still the value will lie between these ranges only. The values are going to lie between these ranges only. Are we understood this part? Everyone? That the values are going to lie between these two parts only, 4 comma 10. Correct? So now we got the range here. So now we can see our range of maximum sum would be between 4 to 10. Correct? Now we got the sorted range. You can see we got the sorted array here, 4 to 10. Right? So now we can find it out the mid element here, which would be 4 plus 10 divided by 2. We can get 7 here, right? Or 7. So now we are trying to find it out. 1 minute, let me write it correctly. Now we are trying to find it out. Can 7 be our minimum sum or not? Can 7 be our minimum sum or not? Correct? So for that, what we are going to do, we are going to create our segments here. We will say that 7 would be the maximum sum for in any of the segments here. Any of the segments. So let's see. We will iterate into this array. So first, let's see. For first segment, so we will take first element 1. Can this element come into this segment? Because we have to create the segments, right? So for the first segment, can 1 can come into this segment? Yes, because we are saying the maximum sum could be 7 here. So 1 is smaller than that. So yes, 1 could come here. Right, guys? 1 could come here. Let's see. 2 can come here. Yes, because the sum of these two elements is still less than 7. So it means we can go for 2. We can see 3 can come here. Yes, 3 could also come here because the sum of these three elements is still less than 7. So these three elements can come here because our maximum sum should be 7 or less than 7. So we are going to keep everything in one segment. But as the 4 will come, as the 4 number will come, we will see that our sum is going to be greater than, because the 4, as we will keep the 4 here, sum will become 10, which is greater than 7. So it means 4, we cannot keep 4 in this segment. If we will keep the 4 in this segment, our sum will not be equal to 7 or less than 7. So that's why we are going to keep our 4 in another segment, and that will be second segment. Now we do not have any other segment, right? So now we can say if our sum is 7, we only need two segments. We only need two segments. But our condition was we need to create three segments. We need to create three segments. It means 7 is little bit larger. 7 is little bit larger number. Because if we are going to keep 7, so we are only getting two segments. So if we will increase 7 to like 8 or 9, we will like when the sum is 7, we are only getting two segments. If we will increase this one, it might be possible that all the elements could come in only one segment only. Is it possible or not? If we will increase our sum, then there are like definitely 100% chances that all the element could come in one array only, one segments only, right? So Hariharan is saying between maximum number in array and sum of all elements in array. He was asking other questions, or yeah, that would be our range. Maximum number, yes. So that's why we will not increase our sum here, because if we are keeping our sum as 7, we only need two segments. So somehow we need to reduce it so we can get more segments. So that's why we will move into the left side. Correct? So now right will become mid. Now our right will become mid, and this will be same, right? This will be same. Now you can see we have reduced our array. This is right, this is left. Earlier array was this much. Now we have reduced this to 4,7. Let's calculate the mid again. Let's calculate the mid again, which would be 4 plus 7 divided by 2. 11 divided by 2, which is 5. So now 5 is between here somewhere. This is our mid, next mid. Now let's look for 5. Again, try to divide the segments. Correct. So let's see. In first segment, 1 we are taking, it's less than 5. Okay. We are taking 2. So the sum of these two elements is 3, is still less than 5. Let's take 3 here. As we were taking 3, the sum of these 3 elements is greater than 5. So we cannot take 3 here. So we have to now create the next segment here. 3 could not be come here, right? So now we will have to keep this 3 in next segment. Now let's take another one, 4. 4 can also not come into this segment, because if you will add 3 comma 4 like this, 3 comma 4, it will be 7, and which will be, because we are saying we can only keep maximum as a 5, so we cannot keep the 4 here. So 7 cannot come here. So we need to create another segment here, right? So the 4 will come here. So now you can see 3 segments are here. 3 segments are here. So now this could be one possible solution. So our possible solution is 5. This could be our one possible solution. But why this is not only the possible solution? Because they are telling us to find it out the minimum. They are telling us find out the minimum minimum sum here, minimum maximum sum. This is the 5 is maximum sum. All of our segments are good here, but they are saying we need to find the minimum value of this. So we have to try a little bit lesser also. Correct. So that's why this time we will go for little bit lesser also. So again we will go into the left side. We'll again go into the left side. Correct. So now understood, guys? Repeat last time. Okay. So see, our possible solution is 5. Our possible solution is 5. Correct. Well, 1 minute. Let me check. Is this the correct or not? Like this segments are right, guys? So 1 comma 2 is 3. And we cannot add 3. 3 is there and 4. Right? Our segments are correct. Yeah. Yeah. So our segment is correct. So now we are saying if our mid value is like, if our maximum sum is 5, we are okay. We are okay. We can take that as a one possible solution, because our elements are properly segmented, right? But they are saying that we need to find the minimum value. This could be one possible solution, but we will check for the minimum value also. So for that we will go for the or might be we could go like we can increase our left range also. So if we will increase our left range, so it would be no, I think left range we cannot increase. We only have to go into the right side, because we have to find the minimum, right? And minimum only we can find when we will move into left side only. Correct. So that's why now our right will become 5. Right will become 5. This was our range. You can see, guys, we started with 4 comma 10. Now our left has become 4, right has become 5. Now we will again find out that with one minimum value, are we able to do that or not? So now our mid would be 4 plus 5 divided by 2, which would be 4. Correct, guys? Which would be 4. Now let's look for 4. So 1 comma 2, yes, they could come here, but 3 cannot, because the sum will become 6, which is greater than 4. So the second segment would be 3 and 4, this will be 4. So now we got another possible solution, which is minimum than earlier. So what we will do, we'll take next possible solution as a 4. Next possible solution as a 4. Now we will still not stop here. We will again reduce our right to one more point. we will reduce our right to one more point, and we will check for the next minimum value also. We will check for the next minimum value also. Right? So now our right will become 4. Right will become 4. So if we are like keeping condition like this, start less than equal to end, then in this condition we have equal, we will go one more time inside it. We will go one more time inside it. But if our condition is of while loop is start less than end, then I think we will not go further than this. We will not go further than this. Understood, guys? If our condition this, the next iteration is totally depend on your while loop condition. If you are keeping your start and end less than equal to, we'll go one more time. And if we will go one more time, we'll get the same result, because 4 plus 4 is equal to 8. 8 divided by 2, 4. And then our right will become 3, because we are reducing our right. Right? And then you can see here, we'll see we will be stopping our condition here. Correct? Everyone understood this part? The last thing, and that's how we will reach our possible solution. And let me show you in the code also for the split one. So you can see first we are trying out the finding out the max element in the array, which would be our lower. So first we find it out the maximum element with array dot reduce. Once we find it out our maximum element, like we are taking this example, I think, yeah, 1 3 2 4 10 8 4 2 5 3. So the maximum element is 10 here. So this will be the like lower range from where we will start. Then we find it out the end value, where we have added all the arrays element, which was 42 in this condition. Correct? Then you can see here I am using less than equal to. It means I must be doing start is equal to mid, end is equal to mid minus 1. So you can see whenever our solution is verifying, whenever our solution is verifying, we are simply subtracting it. We are simply reducing our end is equal to mid minus 1, because we have to find the minimum value. Correct? And then if I go for how we are checking the values, so you can say here we have taken one sub array where we'll keep all of segments which we have created. This is the sum elements where we are trying to add elements like this. 1 plus 2 plus 3. When we have created the first segment, we are trying to add those elements, right? 1 comma 2 comma 3 like this. So that's for keeping that sum, we have taken this variable. Then we are checking here if array of I greater than mid. If any of the arrays element somehow mid has become that much low that it has come into the condition where array of I is greater, and those scenarios we have to simply return it, because this condition is not true. Then we are just iterating into the loop, adding our elements. We have to add till we have to add all those elements only till then when the sum of those elements are lesser than our mid element. So we have added those elements, and then as the sum is becoming greater, we will create a next segment and then updating our sum for next element. So the next element whoever is come will be added into the next subsets, because 1 2 3 is there. Now 4 will come here, then the 5 will come here. So now we will start adding these things from this element, not from the previous sum. So that's why we are assigning sum is equal to array I. So now the sum will start from this element. And then in similar way, at the end, when all the segments are ready, we are checking our sub segment. If our sub array segment is less than or equal to if they are smaller or equal to the provided segment, we are returning true. And when we are returning true, we are just going into the left side, because we have to find the minimum value. If somehow our segments are not, like if we are creating more segments, then in those scenarios we have to go for the right side. Like if in some scenarios, if our segments are coming like more than the provided, if our sub array or segments are coming more than the provided, like in this problem 3 was provided, but if somehow if our sub arrays are coming 4 In those scenarios, it means we have to go to the right side because we have taken very less value. Okay, guys. So that's what the sub from line 14 once again, please from line. Still you want to why sub array plus plus in line 19? Line 19. Oh yeah, line 19 because we are not taking sub array as a one. Because see, if this line could be removed if we add sub array is equal to 1 here, because we are starting our sub array is equal sub array is 0 and then we created first segment. We are creating only first segment inside our once we are getting the values. What about the last segment? What about the last segment? So that's why always we will be having the plus plus here, because because if we keep our sub array as 1, so it means first segment we are trying to find out the elements who are going to keep in first segment, but we have not created any segment for those elements. We are only creating first segment when the, let's see why this is happening. Let's take the same example 1 2 3 4 5, and if our sum is a 4, if our sum is 4, so let's see, so we have not created any array segment. Segment is 0 till now, right? Segment is 0. So now what we are doing, 1 plus 2. So till now sum of these two elements are less than 4, correct? Less than 4. So now we are okay. Now next element is coming 3. So as the 3 will come, 1 2 plus 3, it would be greater than 4. So now this time we are creating first segment. So now our segment would be 1, and 1 comma 2 will come in this first segment. Now let's look for next element, which is 3 or 4 comma 5. So 3 will come here, right? As we will keep 3 plus 4, right, it will become 7. So we have to create another segment, so which would be 3 comma 4 next segment, correct? So now our segment will become 2, correct? Now we need to keep the 5 also. We have created the 5, which is also greater than 4, which is also greater than 4. So now we have to create one more segment, which is 3, right? So the next element who will come, that will come in this array. So that's why this calculation is not happening anywhere. So that's why we have done the sub array plus plus, because in the fourth array, because we are not keeping the fourth segment. So that's the reason. That's the reason we are doing, but you can see fourth segment has already happened. This is the first segment, this second segment, this third, this is fourth. Already fourth segment has been, for this scenario, fourth segment is already there. Understood, Hariharan? Why we are doing the sub array plus plus at the end? Because you can see with the example I already showed you, now the fourth segment has been created here. This is the first segment, second segment, third and fourth, correct? But there is no element in the fourth segment right now, but segment has been already, fourth segment is already happened there. Understood, Hariharan? And we can reduce it. If we will start from sub array is equal to 1, it means we are saying that whatever element we are trying to add, those are going to be in this first segment. Then we do not need this particular sub array plus plus part. Got it? That's the reason we are doing that. Okay, so Arad is saying, can you run the code? Sure. For this scenario, let's see the answer. We'll take the earlier example also. So node, for this 12 is coming, but let's take the earlier example, which we are trying to solve. 1 2 3 4. 1 2 3 4, and our segment was 3, right? Let's see. Yeah, the answer is 4. Let's see if I change this to 1, and if I remove this condition, still answer is 4. That's what we are not telling that this is our first segment where we are going to keep elements. That's why at the end we have to keep the sub array plus plus. Okay. Hariharan saying from line 14, yes sir, got it. Please explain line 14 and line 20. 14, line number 14, this. right? This one, right? So this one is that part, right? Hariharan, where we are checking our sum should be greater than mid element, this condition. Yeah, this one, our sum should be greater than mid element. This is the condition, is the line number 14. You see? And once our sum is greater, we have to create the next segment, right? And when the all sub arrays, all the segments are created, we are checking those segments should be equal to our like provided segments or less than, then we are returning true. If they are more, then we are returning false. Where are the chat? Yeah, got it? Okay, so now this was the second question. We can go for break now, guys, and then we can come for the median question. Okay, we can understood the median question which Vishal was saying. So we can go for break now. So right now it is 10:18. No problem, Ariel. No problem. Now it is 10:18, so we could come back at 10:30, or yeah, 10:30 is fine. Okay, everyone. Let's come back at 10:30. And if you want to like understood any other problems, please let me know in the chat. Hello guys, I'm back. Everyone is back. Okay, great. So let's quickly jump into the median one. Okay, and then we have time, then we will look for the next question. Okay. Yeah, so median of two sorted arrays. So what they're saying, they will be providing us two sorted arrays, and our task is to find the median of these two sorted arrays, where the number of elements in the first array is n and the second array is m. Okay, so let's see. Let's take the example there and let's first understand these things. You guys have joined my last class. You guys must be aware of the median, how we calculate the median. So it's a 7, 12, 14, 15, 7, 12, 14, and 15. Another array is 1, 2, 3, 4, 9, 11. Right, guys? These are the arrays which they have provided us. And they are saying us to find it out the median. So if you guys remember, median is the element which divide our array into half. Median is the place in our array which divide our arrays into like half of elements, like left side and right side would be equal in the even scenario. So like if I talk about the even scenario, if our array's length is even, like let's talk about 1, 2, 4, 5. You can see this array's length is even, right? So if you will try to find out the median, so median would be the place which will be dividing our array into the equal part. Correct? Median would be that place. So right now, so the median for this array would be the sum of these two elements divided by 2. So the middle part. So this would be 6 divided by 2 will be 3. If there would be 3 in the middle, that would be the median here. Okay. In the odd scenario, in similar thing. In the odd scenario, also similar thing. So median would be the element which would be dividing our array into similar parts. You can see 2 and 2. Understood? This is the median. Are we good with understanding the median? Let me know in the chat. Everyone? Do you guys confused about it? Ah, okay. Yes, you said only. Okay, understood. Okay, great. Arad is saying no. So see, Arad, median, very simple definition, is the place which divides our array into half elements. Is the place which divides our array into array or our numbers into half of them, where left side of that medium or right side of medium number of elements should be equal. So you can see in the even scenario, when we have even numbers, like number of elements are even, you can see the median would be somewhere in the middle of 2 and 4. So that will divide our array into two parts, 1, 2 and 4, 5. You can see length is still 2. In the odd case, if the number of elements are odd, you can see the 4 would be the median, which we will be dividing our array into two scenarios. Same length, 2 and 2. Okay. Oh, okay. You guys sometimes say yes, no, that's fine. Okay, so that was the median calculation. Let's think about. See, in the if you want to do it like through the brute force, it's very easy. In the brute force, we do not need to like apply anything. We just need to sort this array. First, we need to merge it, then sort it, and then we, based on the length, we can easily find it out. Let's see quickly the brute force approach. So the sorted merge array would look like this: 1, 2, 3, 4, 7, 9, 11, 12, 14, and 15. I hope I have not left any element. 6, 4, 10, 6, 4, 10. Yeah. So now the length is even. So now it will be somewhere this. The 5 element would be this side, 5 element would be this side. So the median would somewhere between these two, 7 plus 9, divided by 2. So the median would be 8. Let me check my answer. Is the median is 8 or not for this problem? Yeah, it's a 8. Let me see if there is some doubts. Okay. So Ekta thinks that the internal sort algorithm takes n log n. Yes, this takes n log n. So that's what the time complexity would be here. N plus m log n. That would be time complexity for sorting this array, right? And then after sorting it out, we can simply find it out the 7 plus 9, right? This would be similar like array length divided by 2 and plus array length divided by 2 minus 1, right? Because this is, see, this is the, if we say the length of array is 10, length of array is 10, so half of this would be the middle element, or the middle would be 10 divided by 2, which is 5. So we just need to add middle element plus middle minus 1, and divide by 2. So middle element as the fifth index, I think this one 0, 1, 2, 3, 4, 5. Yeah, it would be 9. And middle minus 1 would be 7 divided by 2. This is for even case. If array is not even, we just need to find it out the middle. That middle would be our answer, the fifth. If we take one more element here, 6, so then this, I think the array would, like, array length will become 11. 11 divided by 2 is still 5. And 0, 1, 2, 3, 4, 5. So this would be the answer. 9 would be our answer in the odd scenario. Okay, understood, guys? This was the brute force approach, where we will be taking the like the complexity would be n plus m log n, because we have to sort it, and after sorting out, very easy steps. But we have to somehow reduce this problem to n log n, sorry, log m plus n, rather than sorting it out, because our arrays are already sorted out. So rather than sorting it out again, we have to find some ways so we can, okay, 1 minute. I just came into some other page. 1 minute, guys. So yeah, so rather than sorting it out, let me write the R arrays again. 7, 12, 14, 15, 1, 2, 3, 4, 9, 11. Okay. So rather than like doing this sorting, we need to find some of the ways so we can simply look into this array and somehow, like, if we somehow without sorting can get our answer. So let's see if, like, the combined array of R looks like this, right? 1, 2, 3, 4, 7, 9, 12, 11, sorry, 11 would be first come, 12, 14, and 15. Correct? This is our array. And because we know that our median would be the place which will be dividing our array into half parts. So this would be our median, which would be dividing our array into half parts, which would be 5 here in this scenario, which would be the 5 here. Correct? Are we understood this part, that the median would be the place which would be dividing our array into half parts? Correct, guys? Everyone? That's right. You sorted it already. Yes, already sorted. Like this would be our final string, right? If we will combine these two arrays, so this would be our final string. And in this final string, we can observe that, see how we approach for logic. We finally go for the solution, then we try to go backward from there, right? So this is our final string, final sorted, and then we can understand that if we try to find out the median in this final string, then there are some of the observation which we can look, that the median would be dividing our element into equal numbers, and that number would be 5 in this scenario. Agree, guys? Right? So now we got to know that somehow we need to create these 5 elements. and automatically these elements will be created. Because 5 elements are there, then the remaining 5 will come this side. And because this array is already sorted, these above arrays, the like array 1 and array 2 is already sorted. So somehow we need to create these 5 elements in this side, and automatically the remaining 5 will be going there. Right now you can see these 5 elements are coming from both arrays. Right guys, these 5 elements are coming. Now see, you can see now I'm going backward. One by one I am going backward. So first we created whole string, whole combined array here. Then what we observe? We observe if we somehow we have to create the median here. So that median will divide our array into half of elements. It will create the like left side 5 and right side 5. Right now I'm talking about the even scenario. Odd scenario I will talk about, but right now I'm talking about the even scenarios. In even scenarios, always this will happen. If there are 4 elements, 8 elements, 6 element, or 12 element, 14, 100, it will always create the median will be always be in the middle. It will divide our elements into left and right. Okay. Now on the left side, you can see if we somehow have to create this left side, so you can see we need to take elements from both arrays. Right, guys? We need to take the element from both guys. You can see from the first array we have taken 1, 2, 3, 1, 2, 3, 4, and the second array we have taken 7. So somehow now we need to find it out, guys, how many elements we need to take it from any of the arrays. And then, so there is one, you can see there is one variable come into the picture. There is one variable comes into your picture that is telling how many elements we have to take from one array. Because see, if you will take 2 elements from array 1, then for creating this 5 elements we only have to take 3 elements from the array 2, because we have to create 5 elements at one side. So only there is one variable, that is x. We need to find it out this x, and if somehow we have find it out this x, we will just subtract it, because for the next array the 5 minus x, next array 5 minus x. So there is only one variable, and that variable is x. How many elements we need to take from any of array? It's not like array 1, any of array, because if we find it out this x value from one of the arrays, then we can understood the next remaining elements we have to take from the next array. Are we understood this part, x 5 minus x, guys? Okay, I'm not getting. Okay. So everyone, guys. Okay, so we know that this median part you understood, Suraj? That our array would be divided into 5 and 5. This part you understood? Okay. Okay, Suraj. So now the next thing is, हमें ये पता करना है, we need to find it out कि हम ये 5 elements कैसे create करें? How can we create these 5 elements? Because these 5 elements are coming from array 1 and array 2 together. Correct? The 5 elements are coming from array 1 and array 2. So now there would be some elements from the array, there would be some element from the array 2, right? Did you get this part? There would be some element from the array 1, there would be some element from the array 2, correct? So that the value of sum, when I'm saying this sum word, that sum is x here, that sum is x here. So there would be some, like there would be x element from the array, any of array 1, then the remaining 5 minus x would be from the array 2. Because if we have chosen x element from the array 1, then how many elements are remaining? This is 5 minus x, and that will be in array 2. And we are not sure about what is array 1, what is array 2. From anywhere we can take x element, then from remaining array we have to take the 5 minus x. Now did you get it, this part? Yes. So that's what we are trying to do. Sir, array 1 and array 2 are input, or we are split. Yeah, that's the input, Hariharan. See, they have given us 2 arrays, 7, 12, 14, 15. 1, 2, 3, 4, 9, 11. Okay, Hariharan? So now everyone has understood, right? Because see, we are going backward now. First we have decided if we merge these 2 arrays, we'll get some array like this. Then we decided if array looks like this, then the median would be dividing an array into two parts, and the maximum element will be in the one part would be 5. That's the thing we did. After deciding this 5, now we need to identify which are those 5 elements. Which are those 5 elements which we need to keep here. And these 5 elements will come from these two arrays. These 5 elements will come from these two arrays. So that's why we need to take some elements from the array 1, some elements from the array 2. And that's what that sum is the variable x here. That's what. So we will take x element from the array 1 and then 5 minus x element from the array 2. So let's try to do that. So let's see, I am taking 3, my x value is 3 from array 1. From array 1. Okay, so let's take it. So we are taking 1, 2, 3. Now 2 elements are remaining क्योंकि एक साइड पे 5 elements होने हैं. So 2 element 5 minus 3 would be 2. So 2 elements from the right array 7, 12. अब remaining elements because this is sorted array they will look like this. और हमें उसके ज्यादा मतलब भी नहीं है. 3, 4, 9, 11 and 14, 15. Correct? This is one division we did. Now I want to take 2 elements from the array 1. From array 1. So this will look like this 1, 2. And now 3 elements from the array 2. Kyunki 5 minus 2 is equal to 3. So we will take 3 elements here 7, 12, 14. And then here it would be 3, 4, 9, 11. And here it would be 15 only. Did you get understood how this thing is happening? Is splitting how we are taking the array 1, array 2, because we have to create 5 elements on the left side. This is our left side, this is right side. And now we are deciding for creating this 5 element, which 5 element I have to take. Which 5 element we have to take. So for that, there will be some element from the array 1, some element from. And now, how we will be deciding which combination is correct? There could be one more combination, right? X is equal to 1 from array 1. There could be one more combination where we will only take one element from there and 4 elements from the whole array from here 14, 15. And then there would be 2, 3, 4, 9, 11. And then here would be 0 or infinite, right? There could be one more scenario where x could be 0. There could be one more scenario where x is equal to 0. In those scenarios, here it would be 0. Here we would be taking 7, 12, 14. I think this scenario will not work because from the right side only 4 elements. So in this condition, we will stop it. We will not go for right and left for when x is equal to 0. Because 5 element we cannot create. If we have to somehow take one element from the array 1. Otherwise, we cannot create the 5 elements. So that's why I just not taken the last. But yeah, there could be one more condition, x is equal to 4. We have left that condition. The first condition, x is equal to 4. Then we will take one element from the array 2 only. So in that scenario, it will look like this. Let me go down. We can take here. X is equal to 4. So that in that scenario, it will look like this. 1, 2, 3, 4. And only one element from the right second array. And this will look like 4, 9, 11. And this will look like 12, 14, 15. Correct, guys? First tell me, did you guys understood this split or not? Understood everyone? Suraj, Arad, Hariharan, everyone? Great. Now let's move into this. Now we got these 4 splits. Now we got these 4 combination of x values. Now we need to decide which one is correct here. Which one is correct here? हमने तो we have randomly taken like 3 values from array 1, randomly taken 2 values from array 1, randomly taken 1 value, randomly taken 4 value. Now which one is correct here? That we need to decide. And now how we will be deciding? For that, guys, first you have to understand all the left element should be greater than right element because this is sorted array. This is sorted array. So all the left side element should be greater than right element. Are we agreeing on this one or not? Are we agreeing on this one or not? All the left element should be, oh, I'm saying it's more greater. Oh, sorry. Yes, all the left side element. Oh, yes. Okay. I might be saying the wrong thing. Yeah. So all the left side element should be lesser than right element. Correct? All the left element should be smaller than the right side element because this is sorted incremented array. Same condition we are going to check in these partitions also. All the left element should be smaller than the right element. Let's check it from the x is equal to 4. Check it from the last one. So we'll only consider the last elements in our splits. So we'll consider this is the first element 4 comma 7. Here we have 9 comma 12. Correct. So this 4 should be lesser than 12. This 4 should be lesser than 12. And this 7 should be lesser than 9. This 7 should be lesser than 9. So you can see, is this 4 lesser than 12? Yes, this 4 is lesser than 12. Same goes here also. This 7 is also lesser than 9. So this could be one possibility here, that our condition is true, that our partition is correct. But let's check about other partitions. Let's check about other partition. Let's take x is equal to 1, 1 scenario. So you can see 1 is lesser than infinite. Yes, it is. So 1 is lesser than infinite. This condition is true. But 15 is not lesser than 12. 15 is not lesser than 12. And we are saying that all the elements at the left side should be smaller. But 15 is not lesser than 2. 2. This is 2, sorry, not 12. 15 is not lesser than 2. So that means this is not the correct partition which we did. Let's look for x equal to 2. 2 is lesser than 15. Yes. 2 is lesser than 15. This is condition true. But the 14 is not lesser than 3. 14 is not lesser than 3. So we will say that this partition is also wrong. We will look for x equal to 3. Is this partition correct? So we can see 3 is lesser than 14. Yes, 3 is lesser than 14. And then we can check 14 is lesser than 3. No, 14 is not lesser than 3. And why we are doing cross? Why we are doing cross? By the way, this should not be 3. This should be 4. Why we are doing cross? Because if we talk about the same array, because this is same array, this is already sorted, guys. If on the first side you can see this is already sorted, so we will compare it. Always we will get true condition. That's why we are checking the cross, because we are merging. Without merging we are checking these things. Otherwise we have to merge these arrays. See, I am just trying to answer this question why we are doing cross. So reason for doing the cross is because if we are not doing this thing, if we are not doing the comparison for cross, then like we have to, because we have to merge these arrays and we have to find it out the all the elements of arrays, right, which are greater or lesser, because because these 5 elements are going to merge, because we are saying these are the 5 elements these are the 5 elements we are going to keep on our left side. So it means all these 5 elements should be lesser than all the right elements. So that's why we are comparing the cross also. Because if we are not comparing it, it will look like this: 1, 2, 3, 7, 12, then 4, 9, 11, 14, 15. Is this the sorted array? No, right? This is not the sorted array that we were looking. That's why we are doing the cross comparison. Okay, guys. So once we find out our true partition where all the conditions are verifying, and our condition was this, like if we consider this is the left side, we can say this is left 1, we can say this is left 2, we can say this is right 1, this is right 2. So our condition will look like this: L1 should be lesser than equal to R2, and L2 should be lesser than equal to R1. Right, guys? Did you understood this condition, guys? Yes, I think, yeah, that's right. This 3 should not be here. Correct. I just erased it. Okay, so this is the condition. So now, guys, once we now let's see, we will reject all this scenario. So now we'll find it out only this scenario. Okay, so now we got that this is the position. Now we got the L1 values. L1 value is 4, L2 value is 7, R1 value is 9, R2 value is 12. Now we got these values. We just need to find our median here. We have not find our median. We have here only we have decided that if our median if it is an even number, then our median will decide divide our array into half and half part. But this was not our median. We were just simply saying if the array is even, then our median will divide our arrays into half and half part. But now we have to find out the median. So the median would be the maximum of these two elements. Maximum of these two elements. So maximum of these two elements is 7. Maximum of L1 and L2, L1 comma L2 would be 7, and minimum of R1 and R2, which would be 9. Now we need to add simply these two numbers and we will get it 8. Because if you'll see, if you will merge this array, this will look like this only. This array 1, 2, 3, 4, 7, 9, 11, 12, 14, 15. And these two elements will only give us the median. So that's what we are doing it. Right, guys? Did you understood this median part? Everyone understood this median part for even number of elements in array? No, Vishal, we have to go back. See, that's right. That's right. But we have to go backside, right? We tried to traverse backside and then we started thinking about it. What could be the reasons here? And everyone looks logical right now. It's not like that. It's not looking logical because see, first we decided if this is our final answer, if this is our final sorted array, somehow we get to know that our median will divide our array into 5 and 5. Correct? First thing is this. Then the second thing we need to think about that how can we create these 5 elements? How can we create these 5 elements? And once we are having this question, how can we create these 5 elements? Then we have to look for and see these conditions we can easily make false because left cannot be greater than right. Left side of elements cannot be greater than right. So that's why all the partitions are going wrong. This is only the true partition. And once we have seen this is the true partitions, then the next thing which we need to check, how can we now get the how can we now get the median here? So median would be the greater on this and lesser on this side. I think once you understood this problem, I know like at the first attempt it would be very difficult to think about it, but that's right. It would logically we try solving it our own intuitively may take some time. Yes, definitely it will take some time. And but yeah, that's totally true. We could easily solve this problem with like linear approach, but because we always try to go for best solutions, so that's why we have to think little bit extra. Yeah, but yeah, because see, once you are solving these problems, so you can understand how deep question can take. See, what we say, we only think that much how whatever we have seen. Somebody has said that like हम उतना ही सोचते हैं जितना हमने देखा है, right? हम उतना ही सोचते हैं. So now you have already seen how deep you can go into these questions, how deep you can think about these questions. So it has already opened your mind, like that much thinking could also be applied to these type of questions. So next time when you will get like any different question, you will always have something in your back mind that this question could be go in that much level also. I should be thinking in that direction also, right? So Vishal, I think definitely you have solved this problem. You have seen this solution. Now you can think for hit and try. Now if you will try the next hit and try question, you will definitely think till that level also. Am I right, guys, or not? Will you guys will think in that much level or not? Right? No, but because now you are open to it, right, Likit? Now you can see. Now if somebody is saying to you that you need to somehow find the best time complexity, like you have first see in the interviews, always go with first brute force approach. They all will agree. You have to give them first the brute force approach, right? You have to find out the solutions first thing. Once you get the solution, if the interview is interested, if the interviewer is interested, then they will tell you, can you solve this with better time complexity? Can you solve this with better time complexity? They will say this to you. And once they will say this to you, then again you should be striking your mind like there could be some binary search ways. And then whatever solution you have solved till now in the binary search, those all idea will start coming into your mind. Okay. But it takes time to think these logics. Yes, definitely. See, in interviews, the interviewer also help you. While see, that's why they say that once you are thinking about some logics, so they say that speak and talk about it. So once they will talk about it, they will give you directions also. That yeah, you can go into that direction. So that's how it helps. But yeah, so see, once you will solve like more than 100 problems like this, your mind will automatically become so sharp that you could easily catch it. Right now, it is looking difficult or hard for you, and you guys are thinking, I cannot think about logics or anything like that. But once you will solve this type of problem 100, I think next time I'm saying once you get the 101 question, automatically you will not think like this logic was very difficult or like that. Okay, right now it look like it's looking like how can somebody think like that? Yeah, but yes, with practicing everything will come into the picture. So let's see, one we have left one more scenario which was left, which was the odd scenario. If our length is odd, let's take the same example 1 2 3 4 7 9 12 11 12 14 5. We will still divide the array into similar way: 1 2 3 4 7 9 7 9 11 12 14 15, and we can take 16 also. Okay, this is our array which is you can see 5 or 6 11, which is odd. But in this scenario we will again divide our array into the similar m plus n divided by 2, m plus n divided by 2, which will give us again 5. So now there would be one element which could be extra on right side, which would be extra on right side, which would be extra on right side, because in right side it is 6, but we will try to generate only the 5 elements, only the 5 element array. And then once we will reach to this, only for the odd number of that you have to take it from the once you will try to find out that L1 L2 R1 R2. Once you will get that, so you just need to find it out the minimum element of R1 and R2, minimum element of R1 and R2. This is one way, minimum element of R1 R2. Or sometime people what people does, people put plus 1 here, m plus n plus 1 divided by 2. So this would create a 12 divided by 2 6. Now this extra element will come into left side. Now that extra element in the odd scenario will come into left side. You can see now we have to take the 6th element. 3 3 6, not here, not here. Now this 6th element will come. So now when we will having this thing, and this scenario will again create L1 L2 R1 R2, and wherever that condition is matching, this time we have to take the maximum of L1 L2, maximum of L1 L2. That would be our answer in odd scenario. So this all depends on what values you are taking here. Mn, you are taking m plus ny divided by 2, or you are taking m plus n plus 1 by 2. And this m plus n will work for even also, even scenarios also. So if m plus n is 10 plus 1 divided by 2, it's again will give 5 us. So 5 element will come in even scenarios also. So that's why in our code you will see we have applied this one, m plus n plus 1 divided by 2. And for odd elements, we are trying to do max L1 L2. I will show in the code for the median. You see, while calculating that, we are taking m plus n plus 1 by 2. And while calculating the odd scenario, we are taking max of left A and left B. But if you will take m plus n, then this condition will be changed, and you will be taking the math.min right A, right B. Understood, guys? First, tell me this. Have you understood the odd scenarios also? In the odd scenario, what changes you have to do? Okay, so now Likit is saying, I got this procedure and how to do, but I'm not getting how the logic is working. Which logic? Likit, you can speak. You can speak. Which logic you are talking about here? You are talking about the code? No, I think I'm not able to understand your question. Oh, you mean the code? Oh, okay, code. Okay, let's go through the code also, guys, very quickly. Okay. So let's see. First, understand this thing. Why they are doing this thing? So what they are doing, they are trying to take the lesser length. So right now you can see we have two arrays, right? Yeah, these are the two arrays. So they are trying to take the lesser length while finding out the value of x. This value of x. Why? Because I told you this scenario, right? If we will take x is equal to, like, if we take this array length, so length is x is equal to 3, 4, 5, 6, right? So if length is 6, so the loop will run from 0 to 6. So now, but in the array 2, if there is any scenarios where we are taking array from the array 1 only uh, 0 element, then from array 2 we cannot take 5 elements. From array 2 we cannot take 5 elements because array 2 only has 4 elements. But in this scenario 0, 6, there could be some possibilities where we are taking 0 element from the array 1. So that's why we were always trying to look for the lesser, we always try to go for the lesser length. So that's why you can see they are doing that thing only. Wherever its length is greater, they're trying to swap it. So whoever is the lesser array elements, so they are trying to take that length only. Okay, so let's move further. So first time they have calculated that this part where the median will happen, how many elements will come. So that's the part 5, n plus m plus 1 divided by 2. So n would be 5. Yeah, n plus m plus 1 divided by 2. So that they are trying to find it out if there is a even array, how many elements will be equal at both scenarios, equal at both sides. So that would be 6 plus 5 plus 1, or 6 plus 4, sorry, 6 plus 4 plus 1 would be 5. So that's how we got the 5 here. Then they are starting loop while start is equal to length, and this loop will give us the value of x, right? Now let's see. So this is the value of x. Mid is x here. Start plus and divide by 2. So now we are saying this is the first cut. First cut means this is the value of x which we will take from the first array. These are the values we will take from the first array, right? This is a cut 2. Cut 2 means remaining element. If we have taken 3 elements from the first array, then the remaining element, how many remaining element we will take from the second array. So that's what the cut 2 is there. Okay, now let's move further. Now we'll try to find out the left 1, left 2, right 1, right 2. They are saying left A, left B, right A, right B. For left A, we have to look into the first cut only. So wherever the first cut is there, the lesser than that would be the left A for us. You can see in the examples also. Yeah, if x is equal to 3, if x is equal to 3, it means we have divided, our first cut is here, right? So the lesser than that, this would be the index which will give us the left one, and that index, the same 3 index, will give us the R1, right? So that's what you can see, L1 and R1, you will see left A or right A. In right A, you are taking cut 1, and left A, you are taking cut 1 minus 1, which is x minus 1 or same x. Same goes for right 2. Same goes for the cut 2, right? Where you are taking same values. This will be cut 2 minus 1. This will be cut 2. So that's what you have calculated the left 1, left 2, left 3, left 4. And these are like min values and integer min, integer or max. This is for extreme scenarios. When you do not have any elements on the right side or left side. In those scenarios, these values are helping you. because you have to compare it later, right? Then you are comparing it here. Left A less than equal to right B, left B less than equal to right A. If both are, if this condition match, like the first, this one, right? X equal to 4. For this condition matched. If this condition is matching, then you have to find out the median. If this condition is not matching, if somehow if left A is greater than right B, if left A, this where was the left A was greater than right B? Is there any scenario where left A was greater than right B? No, right? There was not be any scenarios where left A was greater than right B. So see, let's take an example where left A could be greater than right B. Will there be any scenarios? Yeah, there will be scenarios. So for that, yeah, this could be the scenario. 1, 2, 3, 4, 9, 7 would be here, and left A हमें greater करना है इससे, right? Yeah. So here will be all 5 elements will be on the right side, and for all 4 elements will be this side. 7, 12, 14, 15, right? And 7, 12, 14, 15. That was only our area. 7, 12, 14. Yeah, 4, 9, 11. Yeah. If this is the scenario, guys, if x values is 5, if x values is 5, means all 5 elements we will take from the left side. If this is the scenario where the left A is greater than right B, in this scenario, what we need to do, we have to move this left 2 with this element to this side and this array to this side. It means we have to reduce our x. We have to reduce our x. So it will be look like this: 1, 2, 3, 4, and 7. Then 9 would go here. Right, guys? It means if x is equal to 5, we have to reduce it. So that's what the condition is here. If somehow if left A is greater than right B, if left A is greater than A, we have to reduce. We have to go to the left side. That's mean end is equal to mid minus 1. Otherwise, start is equal to mid plus 1. Understood, guys? Great. Now we have some more times. So let's look into the sextuplets problem also. Okay, because that problem was also people were not able to. So is there any specific thing you guys want to understand in sextuplets, or you want to understand the whole logic? Otherwise, we can look other questions also. If you want to know about little like specific scenarios in the code where you guys stuck, so I could explain that one, or you want me to explain whole logic? Who was saying about the sextuplet problem? It was you, Arad, right? Yeah, so you want me to explain you whole logic, or you want me to explain some part of code? Code, okay. So you can turn on your mic. I will open the code and let's see which part. Where is sextuple? Yeah, we have this problem, right? Yeah. Any specific place you want me to understand? You want me to talk about?
Actually, whole code, sir. From
okay, sure. So let's start understanding the find sextuplets. So in the sextuplets, if you guys remember,
so yeah, at line 37, I can understand what are you trying to do.
Yeah, you understood this part you are saying?
No, I can't understand at line 37.
Okay. At line 36, what I'm trying to do, we are trying to create an array here. So array.form, it creates a new array, and we are telling how much element in this array should be there. So we are saying that based on the like if you remember the array's length, if you remember the problem here, there was the notepad. So if you remember, in the array we got 2, 3, right? And in sextuplet problems, we need to find out the 6 pairs, right? So 6 pair. So there was a 6 values, right? A, B, C, D, E, F, right? And they both have different equations, right? Let me quickly write those equations also. Yeah. So this was the equation, right?
Sir, actually, I remember that. I'm asking about line 37.
Yeah. So before that, just let me explain you why we need that.
Okay, sir.
Yeah. Minus E is equal to F. Okay, so equation was looking like this, right? And then we transform this equation like this: A into B plus C is equal to F plus E multiplied by D. And then I told you somehow we need to find it out these three elements, all the sums of these three elements. Then we will be comparing these sums with these individual values. So for only these three values, A comma B comma C, how many combination we can create with 2 comma 3? For that, for these three positions, if you guys remember, 2 factorial, 2 factorial, 2 factorial, because on these three positions these two numbers can come at any time. So that's why we need 8. There could be 8 combination for with the value 2 comma 3 for ABC. So that's what we are doing here also in line number 36 to 37. We are creating one array which is going to keep eight indexes, and at each indexes value will be 0 right now. At each indexes value would be 0. So that's what we are trying to do it here. Okay, Arad, understood now?
Sir, what's that blank?
Can you hear me, Arad?
Yes, yes, I can hear you. At line 37, like how it is working?
So this is the way how the array.form work. If you will check in the array.form takes first parameter as a length, how much length you want in the array, then the second as a callback, where it asks what type of elements you are going to keep at each indexes. So that's how this code works. This is the same line actually code, not in a separate line.
So
This is the whole code actually. The first argument it takes the length, second argument is take the callback, where it tells that it's each index what value you are going to keep. Understood now?
Yes, sir, I understand.
This is the form, how the array.form work.
I'm just confused about that dash.
Dash is like the index. It would be, I think, the dash is, see, this is for everyone. The variables or arguments which we are not going to use in our function. The variables or arguments, it's like more with arguments, more with the function arguments, which we are not going to use in our function. We generally try to keep it with underscore only. We generally try to create with underscore, because this underscore TypeScript also does not throw error that we are not using this variable. I is also we are not using, but underscore is also in the similar way we can say we are not using it. And let's see if this, let's go to array.from. Let's see what is that. Exactly what value will come there. We'll see here. So this is the element, second one the index. So the whole element will come here. If there is already an array, so element will come here. You can see this is the element which we are not going to use it. So you can see this is the array.from, right? 1 to 3. We are trying to create a new array. So this is the array 1 to 3, and then we are passing x. So here x is our element, and the second index would be index here, like this. This would be our index. In our scenario, we do not have an element because we are trying to create an empty array, the new array, and that scenario there was no elements. That's why we kept it underscore. Okay, Raj?
Okay, so is it compulsory to take dash? We can take blank too, like just an empty array. I mean an empty string.
Yeah, I think let's see if it works. Let's see. Const a is equal to, let's see. N is not defined. Okay, so we can give length as a 8. It's still working. Okay.
Okay, sir. Okay.
Yeah.
Got it now.
Okay. Yeah. Any other specific line you want to understand? So the next thing which we are doing, we are trying to solve the first equation or the right side of equation, and then all the elements we are keeping it into the RHS. So we're trying to solve this equation, right? Right side. which is F plus E. These are two equations we has, right? Equal to F plus E multiplied by D. That's the equation we are trying to solve. You can see. You see, F F plus E multiplied by D. F plus E multiplied by D.
The one thing that if
You
like
understood this part? How this is F, how this is D, how this is E, Arad?
yes sir. Sir, I'm confused about line 41. I'm confused at that. Why we are taking ARR of I is not equals to 0.
So array of I is not equal to 0 because we are going to multiply them down, right? Because we are going to multiply it down. So that's why we are avoiding if anywhere in the array, if any element is coming as a 0th. Because see, in this array, by the way, we do not have, like, if I check the elements also in the question, I think we would not be having the 0th there. Okay, they have not explained the whole problem correctly. But I'm just looking for if in array, if we have any 0th condition or not. Otherwise, we can remove that condition. So you have given set of integers where F belongs to S. F belongs to S, D is not. Yeah, they are saying D only could not be 0, but other elements could be 0, right? So they are saying the value, the values of S could be 0, right? So that's why, because whatever we are going to do automatically, already we have calculated, right? For that index, we have already calculated value as a 0. So even if we do not put this condition, at the end we are going to get 0 only, right? Because if we are multiplying by 0, so that's why we are not like going into that loop, because we have already calculated 0 for that index. Got it?
Yes, it's like if we take 0, it will go undefined or something.
Is there any next line you want to talk about?
So after LHS and RHS, what did we do? What did we do? After LHS and RHS, what did we do?
Yeah, after LHS and RHS. So first we find it out the RHS. First we got out the RHS. So for RHS, the array was like look like. See, the array I have already written the array, so we can take that array. So 8, 10, 10, 12, 12, 15, 15, 18. Okay, this was our RHS array for this equation. Correct? Now we need to find it out. Now we need to take one value from here and try to apply it here. First we have to find out these values, then we have to compare, and then we have to find out the lower and upper bound here. Why we are trying to find out the lower and upper bound? Because we want to find out the range, like how many combination we can make. How many combination we can make that with that value. So like see, for the array, for this equation, array would look like this. I have already taken the array for LHS also, which look like this: 6, 7, 8, 9, 8, 9, 11, and 12. This was the second array which we have calculated. Correct? So now you can see, if we see with the human eyes, you can see only these values are matching, right? 8, 8, 8, and 12. Right? Right, Tarat? With the human eyes, we can understand only these values are matching. But now we have to somehow compare these two arrays. We have to iterate into this array and take it out. Like first we will iterate into this 6 part. We'll start iterating at 6 and we will find it out. Is 6 exist? No, it does not exist. So it will not make any combination. 7 exist? No, it does not exist. It will not make any combination. We'll go for 8. 8 exists? Yes, 8 exists at this place. Is there any other 8 exist? No. So it means count is equal to 1. So first combination, we got it. Right, Arad? Then we will look for 9. 9 exists? No, no combination. 8 again exists in this array. So now we'll go for again 8 exists. Yes, count is equal to 2. Okay. Now, is there any other 8 exists? No. We'll say no. We again no, no for 9, no for 11. We'll go for 12. 12 exists? Yes, it exists. How many times it exists? 2 times. So count is will be become 4. And that would be our answer. Let's look into answer. Yeah, answer is 4. So that was the approach which we will follow if we go with the linear approach. Okay, Parag? But rather than doing that, we could use our binary search also, because this is our RHS is our sorted array, and in this sorted array we know that because the elements are already sorted it out, so we could easily get the lower bound and upper bound. Like whatever element we are trying to find it out, we could easily get their range. So see, for 8 in this array, the lower bound and upper bound will be lying at this place. So for 8, the lower bound would be 0 and upper bound would be 1. So now we can say 8 can only make one combination here. So upper bound minus lower bound, it will be 1. So 8 could only make one combination here. Same for this 8 also. For this 8 also, in this array, lower bound and upper bound at same position. So lower bound and upper bound. Again 0, 1. It will be 1 minus 0 is equal to 1. Now same for 12. 12, see, because this is sorted array, so 12, like, because all the 12 will be residing here only. All the 12 will be residing is near that. So we can easily find the lower bound and upper bound for 12 also. So lower bound would be 0, 1, 2, 3. And upper bound would be 3, 4, 5. So 5 minus 3 is equal to 2. So we can say that this 12 will make two combination here. And you can see that this 12 is making two combination here. So now if we will add all these values, 2, 3, 1, 2 plus 1 plus 1 will get 4. Okay, so that's what it's happening here also. Rather than going into the n square loop or n loop, we tried with log n, because we have already sorted out the RHS array. So we are just passing it in upper bound. We are passing the same value with our RHS array. In lower bound is also we are passing the same value. And then once we calculated our upper bound minus lower bound, we are subtracting it and adding it into our result. Understood now?
Yes, got it now.
Great, great.
Thank you, sir.
So, yeah, welcome. So we need write new array and first fill 0. Yes, that could also work. Yes, Likit. Dot fill. We can check that. We can check that thing here. That will work or not. Let's try this thing also. But the array dot from will happen, right? Or okay, new array. Oh, new array we simply avoid, right? Using through the constructor. We need variable, I think. We are doing slash do so that it's 0. It will go to infinite. We are doing slash. Likit, can you speak which line you are talking about? We are doing slash d. Or are there older comments? Oh, it looks like there are older comments. Okay, no problem. Okay, so guys, any other problem? I think we still have half an hour. We can talk about other problems also. I think now we have already discussed all the hard problem. So we can go for medium problems now. Any other problem you want me to discuss about it? Anyone? Any code you want me to go through? Everyone is so quiet, huh? So Vishal is saying for him, he's fine with all the logics. He has to now practice. What about others? So many people has joined. Subhrajit is there. I think he has not talked anything. What about you, Subhrajit? Deepa Kumari is there. Ankit is there, I think. Nayan is there. Ankit is saying, please take a problem from lead code related the question what we have done. Related the problem, let's see in the lead code. So Arad is saying, can I ask something not regarding this module if others don't mind? What is that, Arad? If it is smaller, then we can quickly finish it. Otherwise, we can jump into the next question from lead code also. We could look for and think about the logic there. Or it might be good like findings for you guys that how can we find the questions here. Let's see. I'm not sure about the related question, but yeah, we'll try to find out the filter there. I need to do sign in or what? It's still loading. Huh? It should not be. I forget my password is there. Okay, so let's go into the problem part. Right. So we can search about. Let's see. So depth first search is there. Database is there. I think yeah, binary search tree is also there. Oh, this is tree by the way. So the question will be related to trees. Yeah, 1 minute. Is it there is specific any binary search also? Binary index tree is there. Minimum spanning tree is there.
Sir, on second row it is there.
Which one?
Second, sir, from above.
Ah, yeah, binary search is there. Correct. Thank you. So this one I think we have already solved. Hard is there, right? Let's look for search in rotated sorted array. Let's see. Let's try to think about this. This is medium category they are suggesting, right? So let's read. Let's understood. We could think about anything over here or not. So they're saying there is integer array nums, which is sorted in ascending order with distinct values. So like there will not be any duplicate values. Okay. Now they're saying, okay, you guys remember in one of the problem which we were seeing, ternary search. Do you guys remember about that? Ternary search. We were also seeing something rotation was happening there. So I think something related to that. Let's see. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index, and that index would be greater than 1 and less than nums dot length. So like that index will be like if this is the scenario, so that index will be somehow somewhere rotated. From there that array has been rotated. Okay, such that the resulting array is nums k plus 1 and then goes on and then nums n minus 1 and nums 0 nums 1 nums k minus 1. Okay, 0 index. For example, 0 1 2 4 5 6 7 might be rotated at pivot index 3 and become 4 5 6 7 0 1 2. So they see 0 1 2 3, right? So see guys, what they are saying here, what I understood till now, let's take this example 4 5 6 7 0 1 2, right? So they are taking one array which is 4 5 6 7 0 1 2, right? And they are saying target as a 0. Okay, what about the target? Give given the array nums after the possible rotation and it is target, return the index of target if it is a nums or -1. Okay. If it is not in nums, you must write an algorithm with log n runtime complexity. Okay. So they are saying like 4, 5, 6, 7. Okay. 0, 1, 2, and target is 0, and 0 is okay. Yeah. So 0 is at fourth index. Correct. So see guys, what they're saying, we got one rotated array and we have to find it out the index of that. This is a rotated array and they are giving us target to find in this. And they are saying that like in the target is 0. So they are just asking about that index. Correct. Index of 0. And they are saying, see, very simple. Because see, and second is also like that. Second is also you understood, right? With this 3. So 3 does not exist. We are returning -1. Same for 0. So now, but they are saying, you know, we have to somehow return our solution in log n. If we do not talk about log n, guys, so do you think this is a very difficult problem? If we try to find it out in n complexity, we just iterate into this array and find it out our target and return the index. It's very easy question, right? Let me see in the chat. Correct. This is very interesting question, like very easy question if we find it out in the linear manner. Okay, somebody is saying something. Typed by mistake in this question. If we find upper bound -1 and subtract from array length. Okay, so he's saying, look, Sarad is giving an ideas. So let's see his ideas. So Sarad is saying, for 0, if we find it out the upper bound. So see, Sarad, for finding out the upper bound, our array should be sorted, right? First, our array should be sorted. For sorted array, if you want to do the sorted array, then the complexity will become n log n. Then this is not our solution, right? Right, guys? For finding out the upper bound, yeah, our array is not sorted. Actually, that's what they want us to find it out something here. So without, like, we have to use the binary search here. I think we have to do the that's what you're saying. But somehow we need to make this array something like, so we could be easily get it out our pivot index, right? So I think that they have given the terms here, pivot index. What I'm thinking, okay, Vishal is giving one idea. We can look point for trend change, like the peak element example. Okay, that could be the right. So let's see. So left is equal to 0, right is equal to 1, 2, 3, 4, 5, 6, 7. Right. So like if we calculate the mid, 0 plus 7 divided by 2, which could be 3 at the third index. But see, for the peak element, we were looking for the neighbor element is greater. Okay. So you are saying once we get the neighbor element, we might be getting the. So if see, okay, that's right. 0, 1, 2, 3, 4, 5, 6. Okay. In this element, we got the like the peak element. This is our peak element. Means this is the place from where on the right side elements has started like getting decreased, right? So we can say that this mid could be the pivot index. I think yes, this idea could be work, guys. This idea, see, with the mid, we might be able to reach to that index from where the right side of element has been decreasing. Correct, guys? I think this is with the Vishal idea. I also got one thought, and that thought is with the mid element, wherever our mid element, array of mid or mid plus 1, sorry, array of mid plus 1 is starting less, array of mid. if this is the scenario, we can say that that mid could be our pivot index. That mid could be our pivot index. Right or not? Let me know in the chat. What do you guys think about this? See, let's take any other example also. We might reach somewhere with this idea. So other array is also same, looks like. Others nums is 1, okay. Or we can take the 0, 1, 2, 4, 5, 6, 7, yeah. But that is sorted array. Let's see randomly. Let's take an example. 4, 5, right? And then we can say 0, 1, 2, 3, right? If this is our question, same question, but we have just changed the position. So now still our mid would be 3. Our mid would be 3, correct? Because L would be 0, right will be 0, 1, 2, 3, 4, 5. 5 would be here. 0 plus 5 divided by 2, which will give us 2. So 0, 1, 2, 3, 4, 5. So we can see that now at the 0th position, we will compare this condition. If array of this condition, and this condition will give us false, because array of mid plus 1 is not lesser. So in this condition, we have to move to left side. We have to move to left side, right? So now our left will become 0, right will become mid minus 1, 2 minus 1, 1. Correct? Now let's see. 0 plus 1 divided by 2, which will give us 0, right? Which will give us 0. So now we'll check for 0. Is it greater than? Yes, it is greater than. So now what we will do? We'll move. We will move left side. So left is equal to 1, right is equal to still 1. Now left plus right divided by 2 is equal to 1. Correct. Now we reach to this position. Is it greater than? Yes. So now we could get that mid is equal to 1 is the position from where array has started rotating. From where array has started rotating. Guys, you understood this part? With the peak element, we have understood that Ekta is saying something. Let's see. Sir, actually, I solved this question by taking multiple test input and trying out all the possibilities as to where our mid falls and comparing the target with small bit and as the usual binary search. Solve this question by taking multiple test input and trying out all possibilities as to where our mid falls. Okay. And comparing the target with small mid and as the useful and usual binary search. Okay. Can you explain it a little bit more, Ekta, while speaking up? The
yes,
last
sir.
part, what you're trying to say there?
Yes, sir. Actually, this was like the usual binary search. First of all, we take the mid value, and while entering the loop, we compare. If it is equal to mid value, we return. Then what we do, since we already know that it is rotated, so first half would probably increase. Then we reach the that pivot or that peak index, then it decreases. So we will first compare if the starting is less than equal to mid. So if this first half is sorted, okay, then we enter that if condition. Then we will compare that if the target falls between small or mid or not. So if we know that small till mid it is sorted, then again we will compare that if it is greater than element at small and it is less than equal to element at mid. Then if it is falling in that case, then we will decrease like n equals to mid minus 1, like the usual binary search.
I see.
Yes.
So first we have like the similar approach we need to follow, right? Which I'm trying to do here. But you are saying we have to find the two small mid, huh? We have to find when you talk about small mid and maximum mid. That what was that? Because see,
no, sir, no,
right
no,
now.
No.
Because
actually,
right now you see.
Sorry, so you continue.
So right now you can see we have find it out the position from where array is rotating, and that position is 1. This is the last element, and after that the
everything
usual
is increasing, ascending order.
No, after that, like after that, everything is increasing. Correct. Right?
Yes,
Which means
yes.
it is the sorted part. So we got our mid. So somehow now we need to compare. Now, what is next you are saying here?
Actually, in my case, I am not finding that peak or pivot index. I'm just taking multiple if-else cases. So actually, I told you there are a couple of more if-else cases. The first is that small means zero, sir, like nothing special, like small to mid, whatever we have found, if that is sorted, then we enter that if case. And if our target is between the small and mid, so let's suppose our target is 4 or 5. If it's 4, then like if it's, but in that case it will not fall in that case. Our mid is 2, right? So here in this case, like small is not like less than equal to ARR at mid. 4 is not less than equal to 0. In that case, we will compare our target. Target is greater than equal to mid, and it is less than equal to end. Actually, I'm just partitioning into 2, like small to mid, one part, mid to end. It has to fall in like these either of the two. Like, but since it is rotated, you have to take this 2 couple of, like basically एक if है, एक else if है, जिसमें कि पहले if में हम ले रहे हैं कि if small is less than equal to mid, so it is very obvious that ये वाला part sorted है.
Correct.
Inside that if we are checking if the target is in that range or not. अगर ये पहला जो होल इफ है, अगर ये फॉल्स है, सर जैसे इस कंडीशन में 4 is not less than equal to 0, then what we do, we will see if our target is greater than equal to mid, मतलब mid से end के बीच में है कि नहीं. तो अगर ये भी फॉल्स है, then since it is rotated, we will do like this end is equal to mid minus 1. क्योंकि obvious है कि इस पार्ट में नहीं है, mid to end में नहीं है, तो obviously start में होगा because the array given to us is rotated. बहुत पॉसिबिलिटी है कि इसके पीछे भी इससे बड़े एलिमेंट्स हो सकते हैं. So that is the approach.
Oh yeah, I think that's right. That could be the one way to do that. What about what other things about it? So Sarad is asking, it is like ternary. So no, actually, because in ternary we believe that after reaching to one peak, it could come back to same peak again. But this is a rotated array question. So what is happening here? Well, let's draw it. So let's see. It is starting from 4, 5, 6, 7. So like something like this. It goes till 7. Then it again down, like directly going down, and then increasing it again 1, 2, right? And then again, like if you say the array would be rotated, if it's a little bit bigger array, so then it would be like 4, 5, 6, 7, 8, and 0, 1, 2, and 3. So see, there is only one peak at one time will come. But in the ternary search, I remember this was like this, going like this in ternary search. Right? Right, guys? Where we were seeing the multiple peaks in ternary search. But here, it looks like it's just creating one peak here. But yeah, I think somehow, like till now, as we reach here, mid is equal to 1. Somehow now we need to think little bit more to keep to look for our target also. Something. Let me think about that. What could we do? Do here also. But yeah, I think your approach was also right, Ekta. But what about others? Is there any other ideas the people are getting here? So Likhit is saying, the find the pivot and make 2 half of sorted arrays. Okay. And if arrays end is greater than target, then target lies in second half, else in first half. So apply binary search for that sorted half. Oh yes, it looks like similar to the Ekta's, which Ekta is suggesting. Correct. Right. So we can make the, like we have already taken the pivot. So we can now say that the left side of this pivot element would be the greater elements, or like 4, 5, those are already sorted, and the right side of this 0, 1, 2, 3 is there. Okay, so what else, guys? So yeah, try this question, everyone. We might get some ideas to while yeah, discussing about it and like trying to solve these problems, we might reach to some solution there. We might get some different solutions also. It's not like that we only have to need sort the arrays in like 2 different parts and then go for left and right, right? So there could be multiple ways to solve this problem, but yes, at the end we need to apply the binary search. Okay, yeah, please try this. So yeah, I think if there is no other questions, we could end this session. And because today you have some whole day, and I think you guys have today some other class also, right? So Ansol has told me to leave you guys a little bit early today. You guys have something after 12? Yeah, I remember like Ansol has told me to drop you guys a little bit early today. Guest at 5. He told me at 12 o'clock. Okay, they might have rescheduled it. That's possible. Okay, guys, then we can wrap it today here. And I will request to everyone, please just revise all the problems. And after revising all these problems, try to start looking into the lead code problems like this, as we were talking about it today. We might not solve it whole questions, but yes, we got some ideas that how can we reach the pivot element. And once we reach the pivot element, we just need to think a little bit more about it to find out our target also. Okay. In similar way, try to start looking into these questions on binary search. Okay, so Likith has doubt in making models. Yeah, you can share your screen. We can see that also.
No, sir, not see. I confused in making models, like what all to make us model. In library app, there are given that book list. Books are in the book list. So I have made book as a model and book list as a model. So is it important to make both as models?
So see, book is a model, could be, I think both are needed. You know why? Book will have its own informations like author name, page numbers, book name, right? All these informations will be keeping in the book model. And book list, let's look about book list. So actually what we are going to keep in the book list, is it the number of books or like
ID of book
ID of book? So like why we are keeping it there? Like what is the use case?
Like to search a book is there or not in the library.
In the library, book is so, but library would be a database, right?
Yes.
In the library, we can generally directly search in the book table. So why we are going with book list? We can directly check in the book table, right? With the book model, that book.find and that ID. So we could do directly that. Is there any see why I was thinking for book list? So book list could be,
see, every user has a book list. So in this book list, it is updated that I have taken that book or not.
Yes, that is this is the use case actually. So now in the book list is serving as a like we say like relationship between a user or books, right?
Yes.
It is working as a relationship table, which is telling us which person has been assigned to which book, correct? So then yes, in that case, so this is like association table between user and book. So that's not like related to book table. This table is just the association table, not the main table. Main table is user and book. So book in the book table, we will keep all the book informations, right? All the books with IDs, and then in user table all the users, and in the book list table which you are telling, that would be the relation table between how many books has been assigned to which person, what is the timing of that, is there any penalty on that person, or yeah, all these type of informations,
Okay,
or
then
that person has
then we have to
has
make then we have to make many to many association in books and users.
yes, definitely, because one book can be assigned to, one book can be like
Assigned
used
to.
for many users, and same user can take many books also. Yes, many to many.
Okay. Thank you.
Great. I have doubt in making models. So request params and request body difference. Okay. So Arad, request.params was like this. If I am already sharing my screen, not sharing, 1 minute. Yeah. So request.params, if you can see, if my website is abc.com, and if I'm passing /1 or /test, these values we can get in one and test. These value we can get in request.params. Okay, but request.body only comes, and see, this /1/test is going in post method. These are going in, sorry, these are going in get method. When we talk about the get method, in get method we can pass values in two ways, through the params or through the queries. We can also write the queries here. Test is equal to ABC. In the get method we can pass values in two ways, through the params or through the queries. But in post we use the request.body. Whenever we are passing any data in the post API, those data will go into request.body. Okay, Rat? That was the difference. Yes, we have to give /variable name and access it as a request.parameter.variable name. Totally right. Totally right. Sarah is sharing something, BD6 module test. What is that? Let's open it. Okay, so this was the Asha, this was the problem you guys are trying to solve, huh? Wealthy customers. Customer as wealth. Perfect square. Acha, you guys have already done the test for this, and in that test, you got these problems. Oh, okay. This one you are talking about, the book rental application. Oh, yes. In this table, yes, you will have that. You could create one more model where you can keep how many book has been rented with whom. That's right. There could be three models: user, book, and the third could be the book model, or like user book association model, where we will keep the information about user and books. That's totally right. Okay, guys, I think that's all from today. We will meet in our next class, and I think you guys have now time whole Saturday and next Sunday also, some of the time in Monday also. So please try to do practice. Not Sunday. You do not have time in Sunday. Why? What happened? Oh, you guys have test tomorrow. I see. So like before jumping into the lead code questions, I would suggest everyone to please practice all these 11 questions, understood all the concepts, then jump into the, as I showed you, I have chosen the binary search, and then in the binary search I have started looking into the, and I have started with medium. Start with easy. There would be easy also, right? Let's see. There would be easy categories also for binary search. So I would suggest you guys to start solving with easy questions. Yeah, you can see these are the easy questions. So first try to solve these easy questions, then go for medium. Okay, everyone. But before that, try to go for try to understand all of the practice questions. We have to make three models, or the association will create a book list table. Association will automatically create that. Likit association will automatically create the book list table. You have to create two models only. Yeah, try that. Okay, guys. So that's all from today. Have a nice weekends and all the best for your test. Bye bye, guys.